Van Sullivan, who's on the line right now, is he met these guys a little over a year ago, Rob. And so when they met, he was pretty impressed with what he found. And Dan and I started talking, and he introduced me to these guys as well. And we felt that they had a capability that could fill an important gap that we've seen across the U.S. Department of Defense and our commercial space. That is the automated laying, robotic laying of wiring. And they specifically have a large OEM, automobile manufacturer, who they've been working with and they also have a U.S. DIB OEM who they've been working with that is really interested in their capabilities. And so we wanted to take this opportunity today to show you two of their capabilities. And you say, well, what's the purpose? Well, the purpose is to fill what we perceive as a gap that's more than perceived, that we perceive as a gap to rapidly lay wiring in support of harnesses for production and manufacturing, and potentially for the production of legacy wiring harnesses and capabilities. Now, here's what we need to suspend some of our cultural obstinance toward new manufacturing processes and capabilities, right? So we have a tendency sometimes to get stuck on mil spec and certain capabilities. Well, the only thing I want to ask today, just lost network. Chase went on this journey with we're really excited about, and Steve and Chris are going to kind of what the machines do. To do today as an objective is to learn about the capabilities for these two specific machines, and then we'll start working with you and your team to figure out how we would operationalize it. So we're not doing anything in context. We're showing it to you raw. So I'll pause there to see if you have any questions or comments.
Yeah, Pat, no, I just, you did cut out on the one part where you said suspend. I think what you were getting to was to suspend what I would say are the current constraints of our military production and kind of think about this at first in a greenfield kind of perspective. Did I assume right?
Yeah, I called it cultural obstinance in our manufacturing processes, our inability to move forward because we have constraints that we've applied ourselves that maybe we shouldn't consider. And this is why we brought UAH. And so here with me right now is Ellis Smith. He's the program manager for UAH's RSESC. If you don't know them, Jerry Hendricks and Bob Lindquist oversee that. And so UAH understands and wants to go on this journey as well. And they want to be part of what we're seeing at Q5D.
Okay.
All right. So here we go. You ready?
Yep, looks great.
All right.
I've set it up to show you the flying leads demo first.
Okay.
If that's in the far corner, the monitor here is on good.
Okay, I'm moving around.
The monitor on that corner over there. You'll be able to see.
Ah, very good. Can you see that okay, Rob?
Yes.
Can you kind of explain what's happening right now?
Sure. So at the moment, this is a crimp connector. So we've got a Schlesinger machine in there which strips and puts a crimp on the end of the wire. So it's now offering the wire up to that. So this is the kind of way you'd have to do a mil spec type connector. So it's a bit slow and clumsy, which is what we can definitely do mil spec type connectors that work, but we don't recommend it. It's because it's a slow and clumsy process, but we can do it. So yeah, now strip the wire, and it's now going to place that into a housing. So it's putting that into the plastic housing and then running the wire out onto a sort of a bit of flex tape. Going to create a flying lead. So what you're seeing, this is a roof line. So the piece that you've got in there at the moment is a roof liner for a luxury vehicle. And we're wiring that up. We'll show you a complete one later. We've got one behind us here. So here we are doing the next one. And you can slowly populate a mil-spec dial connector using this kind of process. You want to
Is it my question? It's making it to
You
5 feet.
might have to come over here so they can hear you with the background noise. Sorry, Chris.
So this is a standard abrasion resistor tape in a production. This is a standard off-the-shelf crimping machine. These are standard bandolier of crimps. The wire is approaching a machine, putting the crimp on the end of the wire, and then it's going to insert it in the terminal. Now we're laying the wire across a termination block here.
Hey, Pat, our connection is going in and out.
Mostly out.
Mostly out at the moment.
So if a wiring harness was built in a forest and nobody heard it, did it exist?
I think they're just trying to build suspense right now, to keep you guys hanging on to see what comes next.
For anyone online, just curious, where is the factory located at that we're watching right now?
It's in
So
Portishead. Oh, I'm sorry.
No, go
Northwest
ahead.
of Bristol. It's in Portishead, which is just northwest of Bristol in the UK, straight west of London. About an
Gotcha.
hour train ride.
Okay.
Yeah, and one of the reasons they put it there is they have a wide access to engineers because that's like the UK hub for aerospace. The company actually started in Oxford, which is where I was introduced to them.
Gotcha. Okay. Hey, Chase, any, just based on the short interlude that we've seen so far, thoughts on, as we wait for that to come back up, initial thoughts for the group?
Yeah. So I sent Nick just a quick recap of the demo of the smaller prototype system from yesterday. I gotta say it's impressive. It feeds and forms individual conductor wires much faster than I expected, with little limitation on wire material that you have to use. There was a caveat that depending on your material choice, that'll throttle the deposition speed, but no, I mean I'm pretty impressed. I sent Nick some numbers, used an example of our Net Warrior cables, since those were pretty good production quantities, and the potential savings was pretty significant.
Okay.
Rob, another thought too while we wait. After seeing the live demo yesterday, either if there's an opportunity to go out there or wait for the university to get their system, I think it'd be worth a stop out there. You know, especially if if you were the commander, have an engagement out at Redstone anyway.
Where, so I got it, that facility was in England. Where is the other location that you're tracked to? Are you saying out at Redstone?
Let's test. Can you hear us now,
Okay,
Rob?
Yes.
we hear you, Pat.
We
So
hear you now.
we had a technical issue. It's fixed now. And Chris was given a phenomenal demo. And I want to get back to that. But Rob, you had a question. Can we help answer that question? What were you asking?
We were just, I had asked Chase on some initial thoughts. Chase was talking about, getting eyes on, and right as you guys came back up, we said, understand the factory that we're seeing the operation now is out of England. But Chase, you had mentioned Redstone. Is there a machine coming to Redstone that does this? Or?
Yeah.
I should have clarified. University of Huntsville, Alabama.
Gotcha. Okay. Yeah, Pat, that was it. Okay. Thanks.
Okay, carry on, Pat. Well, maybe they can, maybe they can't. Rob, this is Van. What we're looking at doing at UAH is having a smaller machine, which they demonstrated yesterday, to work with UAH to come up with manufacturing processes for Class 1 and 2 UAVs. And that's specifically what we're looking at with UAH. And then we're also looking at later on getting a larger machine like they're demonstrating now, the SQ-25, and getting that in that National Center for Defense Manufacturing, which I know I messed the acronym up, which they have a satellite in Huntsville, which is right across the street from the engineering campus of UAH. And that would be more of our playground, in Huntsville to, to try stuff, bring people in and, just see what we could do, both in manufacturing parts and modifying manufacturing processes to look for efficiencies, scalable production, et cetera.
Yeah. Hey Van, when is there a timeline when that capability will be stood up at U of H?
Yeah, we're looking at first quarter of this next year.
So for first quarter 26 or first quarter 27?
First quarter 26.
26. Okay.
Yeah.
Yeah, Chase, I would say, from our standpoint, a quick trip down to Huntsville's almost too easy, right? So that would.
Hey, Rob, can you
aligning effort. Yeah.
Rob, we're back. So we're having an intermittent internet in this entire area. And so it could be an EMP. I'm not sure. It's storms. There we go. It's probably lightning. But looks like right now we're back pretty well. Hey, did you hear anything I said on that last soliloquy?
No.
Did not. No.
Oh, that's awesome. So here's basically what I said. And everybody at Q5D was impressed with what we said. Look, the system that we're trying to get to UAH is going to be in the spring, right? And so I would say just after like AUSA in late April, sometimes we'll have the first prototyping capability at UAH. And that's funding dependent. And we're working that through both AMC and UAH and our company, Molrix. The second capability that we want to bring in is going to establish what we're calling the U.S. Technical Assistance Center. We would have that located in Huntsville, and it would be a collaboration between Molrix and Q5D. And we want the Army to come in at that point to start helping identify manufacturing processes, because almost immediately behind that first machine, we think we can have a second machine. And that second machine could be used at Toby Hanna delivered, established at Toby Hanna for you to start, and Chase specifically, to start developing manufacturing processes to fulfill the requirements that you all may have. We've thought first and foremost about the UAS requirement and how this machine and some of what you saw with how it lays it out on a headliner could really be transitioned to what you have to do with some of the UAS requirements. And so it looks like we're doing pretty good on bandwidth. Are you guys okay? I'll answer any questions, but are you okay if we go back and Chris can kind of walk you back through how it lays out the wires and the crimping and the stripping and everything else? Did you get any of that the first time?
We got like, I think the first wire we saw get laid down. The second one, it started getting intermittent, and that's all we saw.
Okay.
So yeah, you know, if the bandwidth is solved, yeah, let's go back. But I did have some questions on that machine that you just talked about. What you talked about perhaps having a second one at Toby Hanna.
Yeah.
From a just so I understand, I assume that, or would we have to pay for it? What, if so, what dollar range are we in, just generally speaking? And is there a lead time, right? When we talk about procuring automated machinery, right, we're very sensitive to the fact that takes time, and it takes alignment of dollars. So just wondering about that.
So that's a great point, Rob. And so as you understand, and our research has been that the DoD specifically is highly interested in capabilities like this, advanced technologies as a service. Mm-hmm. And so the team here at Q5D and using us, Mulrix, in the US, we would deliver you capabilities as a service. Now, of course, there's lead time, there's supply chain issues, and you can see that this machine is highly advanced in its robotic capabilities, and their software is pretty specky too. And so there would be a lead time. Right now, we think that lead time for the first couple of machines is going to be probably 6 to 7 months once we get to the point from a PO. If we can beat that, great. In the future, what we want to do is really, and the team here has agreed to this, they have a work package. And if we decide, if we collectively, the Army, the DoD, and everybody else decide that this is something that we need to invest in, we want to consider options for assembly onshore. That would help us ensure that we understand and we have, I don't want to say the supply chain's dirty now, but we would have a clean supply chain and assembly process in the U.S. to facilitate what Q5D has come up with. Sure.
Follow-up question to that. So, okay, so I got capability as a service, right? Let's say, making a lot of assumptions here, but let's just say, okay, capability as a service, we bring a machine onto the depot. The contract looks like a service support. That would mean, and I'm looking for verification or not, that capability as a service would mean that company technicians would be operating the machine, or would it be Toby Hanna technicians trained to operate the machine? And that'd be part of
the latter, not the former. The latter, not the former. So here's what we see. So we would set up a multi-tiered support agreement. Your team at Toby Hanna would be running the machines to execute the outputs. And I hope we can show you the software, because you're going to see how this is going to be very common for your team, especially, I think you guys are a Siemens shop as well, right? And so as we think about the capabilities that Siemens has, you're going to see something very similar. Some of the things under the cover of the software help accelerate it, but it's the common CAD CAM that Chase already knows. The controllers are they're spec'd up, right? So think of it just like a beefed up automobile. And that's what Chris has done, is he's beefed that up to give it the capability to run what you're seeing today. So we would have multi-tiered support levels. There would be a tier 1 that we would help with simple stuff like, resetting software, making sure that all the supplies are what you need. There's a tier 2 that might require some additional support. And then there'd be a tier 3 where we would have Q5D people identified as part of the contract to help support that higher level, what you and I would call that sustainment level support that may impact the technology, the hardware, the software itself.
Got it. Awesome.
Okay. So
Sorry, I cut somebody
don't
else
want to
off.
lose.
I apologize.
Somebody else have a comment, Van?
Nope, not me.
Okay. Chris, anything to add, you or Steve, from what I just kind of shared? Did I miss anything?
You're on a roll, man. No, you carry on.
Okay, okay. All right, so look, here's what I want to do, Rob. I don't want to lose it. We're going to show you two machines. SQ25 is the big machine. It's doing the headliners. It's laying out wiring in a very complex manner. Oh,
Right.
and let me show you this real quickly. So here's what, and I kind of blew my script, but we're going to get there. So here's what a completed liner looks like, right? So you can see the intricacies of how it's laying this out using a filament to hold down the wiring and running it throughout the entirety of the headliner. This is on a single gantry. They're not like, there's no hand touches on this, and they're running it through a single machine. So 2.5 meters, think of that. And then you say, well, Pat, what if I have one that's going to take more than just the 2.5 meters you have? Well, Steve educated me yesterday that basically if you want to do a wiring harness 100 yards long, he can build one for you in the current gantry that they have established. So this is kind of the finalized product.
Sure.
Now, I do want to do one more run at how the SQ25 strips and crimps the wiring, because I think that's a critical piece. And with Chris here, he'll give you a little bit more. And then we'll take you over to the prototyping machine that UAH is going to use and kind of show you how they've accelerated and advanced from doing a prototyping machine to a no-kidding large-scale production machine. So when you see this machine, the SQ25, automotive industry intends on using this as part of integrated within their production line.
Yeah, so this is an off-the-shelf Schlöniger crimping machine, so you can take any crimp. These are Molex connectors. We're putting the wire into the machine now, preparing it for crimping. And obviously this is running at kind of just lab speed. This thing will run at about 1 meter per second, so extremely quickly, but to stop breaking stuff, we've slowed it right down here. Now the crimping machine is stripping the wire, adding the crimp, and now we're retracting that crimp back into the nozzle to give it a more precise location. The machine's driving over to the connector body down here and rotating it to the correct orientation and inserting it into the crimp. We're running the cable out on some abrasive resistant material to make it into a full loom. And then here we wipe it into a termination block, which the machine can connect that to the wiring loom at large on the rest of the headliner. And obviously we do that for all the different gauge wires we're using, including twisted pairs. And then obviously the glue you can see here on the rest of the substrate. Later processors will lay wire out all over this headliner.
And so, Rob, Chase asked yesterday about some of the gauges, and I wanted Chris to have a chance to just talk about where we're at now and where we may be able to go in the future on the wire gauging.
Mm-hmm.
So this head has been designed to handle wires down to 28 gauge up to about 12 gauge. So we actually are only interested in the external diameter. That's how we handle the cable. So for us in metric, that's a 0.5 mil external diameter up to a 4 millimeter diameter. And in cross-sectional area, that's around a 2.5 mil, 3 mil cross-sectional wire. So carrying 30, 40 amps of current.
All right, so Rob, you can kind of get a feel for how the system works, and it's even better when you get to see it live. But it sits in that gantry. When we think about our future requirements and some of the things that you're going to have to do, think about what Chris just said. He intends to accelerate the production pace of this machine by 7 times, right?
Mm-hmm.
So what you're seeing now will go up to no kidding laying wiring at 1 meter per second.
The target speed for all the wire you saw on the headliner just a few seconds ago, we complete the whole product, including the glue, in under 7 minutes.
All right, Rob, did you hear that? 7 minutes for the entirety of that headliner that I just showed you.
Right. Right.
Okay. And I'm going to go off camera for a second, and we're going to probably move over to the CY10 to give you a feel for what that machine can do as well on the prototyping side. I think we're ready. Any questions as we're walking around?
No, I'm with Chase. It's from what we've seen already, clearly impressive. For the group, Chase is the engineer, right? He's a smart one. I'm more of I think of these and what we're seeing in terms of kind of, Pat, like what you were mentioning, capability, how that transitions into the facility, how that lines up with timelines and requirements. So it's definitely impressive. And at the same time, I'm thinking through what this connects to on our end as far as requirements go. Pat, you mentioned UAS. And as you know, our workload is pretty diversified. So there are quite a number of areas where I think this could help.
Hey, sorry. This is Chief Gerber from CCOM. And to your point, as far as diversification, there's so much stuff in the TACOM and CCOM space as far as wiring harnesses that this could get after.
Yeah. Agreed, Chief.
Hey, and to that point, Rob, I want to show you a few things. And Chris, can you describe what this is?
So this is actually part of the machine. This is the one of the laser control PCBs that we put in the machine. So one of the things we're going to do is we're going to get the machine to manufacture some of its own components. And this is an interface board. So this is also is a fixture, and if you can see the wiring loom that actually comes off the top of this fixture. This is the wiring loom. This is the fixture that's manufactured with all the connectors on. This whole part separates and goes into our product as a piece. All our electronics are mounted on 1 meter square boards, and we intend the machine to wire itself up entirely. So we're trying to eat our own.
I'll say dog food.
So this is like one example. So this is like a three-dimensional wiring loom. The machine's produced in 3 dimensions. But also, these are examples of the machine making wiring looms using much more traditional flap techniques. So, including laying all the cables, we've made this one clear so you can see how the cables are laid inside. This is a more traditional substrate to protect the cables and hold them in place. And these are demonstrators that we can give to you guys to have a look at in your hand.
So, Rob, we're going to move around now, and Martin's going to give us a demo of how the CY10 works. And so the CY10 is not intended for full production. It was one of the original machines that Chris and his team here developed in order to kind of start the prototyping process and work out some of the kinks of the system. But what you'll see here, this is a full software suite. And so, Mark or Chris, can you guys talk just a little bit about the software suite and what you did to make it work?
Okay, so this is the user interface we have. Normally we have a presentation of the part we're manufacturing up here in full 3D. So you can, the machine will look at the code it's about to produce and generate a three-dimensional representation of what's going to happen. So you can see what's going to happen live and before it happens. Standard control devices and interlocks. And if you look inside the machine here, you can see that these are tool stations. The machine is meant to be able to do a whole range of different operations on the single substrate. Here is where we store all those different end effectors, and they might be, for example, delivering glue, different wire gauges, different adhesive methods, or even polymer, printing 3D polymer. Now we come over to the bed here. This is a 5-axis machine using linear guides. On the bed here, we have the substrate put down and prepped for our wire demonstration. And mine's just about to go now. We've prepped the surface here with a few tokens, and you'll see the wire now being delivered onto those tokens and then spread out across the straight. We then take that finished part and laser cut out the profile that you need the final loom to look in. So most of this, what you're seeing is the fixturing. One of the things we're quite proud of is a fully digital process. So it can be manufacturing this part 1 minute, then you just change substrate and it produces a completely different part without any additional tooling added to the machine. And that means it's completely versatile. One of the things we're hearing from the industry is that you need to make the hardware you're purchasing versatile. It's a matter of just selecting the program you want and pressing play.
Rob, can you see that okay? And any questions
Yeah.
from your Chase over what you're saying?
Yeah, so no questions at this time for me. What I'm kind of thinking through in my mind is I'm looking at that the jig setup and essentially thinking through once this capability, right? Imagine a world, right, where this capability would be at Toby Hanna, to Chief's point, how we export it not only to the LCMCs but ensure that PMs are know the capability exists and use it on the front end, and then we would have that fixture for time, right? It's pretty impressive.
Hey, so you see right now, and Chase was impressed with the speed at which this layout was occurring when we showed it to him yesterday. But they also have this is going at demonstration pace. So they have developed this specific machine to move at a much more rapid pace. And they can kind of, Chris, can you kind of talk about how when you really get moving, how this machine can work?
Well, you can see that all the parts which are actually moving at relatively low speed now are made from carbon fiber. So we've reduced the weight of this machine for all the moving parts to very low. The linear motors are actually not like your traditional ball screws. They're an arrangement of magnets and an electromagnet to drive. And this thing will shift around at about 1 meter per second, which is 3 feet per second. And we can deliver wire at that pace. Now, obviously, we're quite early doors and we do things quite slowly as we develop the processes here, but there's no reason why we can't deploy this wire at 1 meter per second.
So that's part of the novel nature of what Van was interested in, and what I've been impressed with since I've been here is to see the speed at which you can use and how they've taken some standard stuff and really souped it up and used capabilities that are advanced technology to ensure that we can achieve the speed rates that commercial industry expects and what we're going to expect as we go into manufacturing.
Hey, Chris, this is Van. Question for you. Can you talk a little bit about the construction of the jig/template that you have there that you're laying the wire in?
Yeah, so we start from a CAD/CAM package, and everything can be digitally designed in the CAD package. That digital design, including all the wiring, can be moved to a CAM package where we generate the code that you see the machine running now. So it's a completely digital process. All the different wiring limbs you need for in-house repair or you're going to produce can be stored digitally, and then you can just recall those designs down at any point. The fixturing you see on the bed at the moment, this piece of black plastic, which is also a laser cut, so that's another digital process. There's nothing here which is handcrafted and can't be produced from a file.
Excellent, thank you. And then I'm assuming to finish this wiring harness off, all you do is just pop the connectors on, right?
Exactly. So what'll happen from this fixture now, we'll put the top layer of the laminate on, and that will complete the wiring loom. And then we use a special connector called an IDC, and it pierces through the insulation in the wire, makes the cold weld to the copper inside the core of the wire, making a good connection. That massively reduces the number of processes we need to make a good connection, and therefore reduces all the risk you get with normal crimping.
And so, Rob, as we think about that, I mean, we get so stuck into cannon plugs and mil spec that we really need to start thinking about how we're going to move forward with these specific connectors and how we can not constrain ourselves by thinking it has to be a milled connector set.
Yeah, I agree. I think we have to get our partners on the acquisition side to be in line with that. But I think if that capability is resident, right, they know they can reach out and work with the DevCom community to test it at a site. I think that becomes a lot easier to I don't want to say sell, but to broadcast the capability to say, hey, here's a direction we should go. Come to the facility, test it out, see what you got, right? Rather than, right? I think what's slowed us down in the past is that um, capability on the sustainment end was always based on what acquisition did first. And so we're constantly in this, trying to it's like trying to catch your tail, where I think, having this capability resident within the OIB, we can offer the solutions to the PMs up front as they're
That's right.
designed.
Yeah, and so the good news is that now, the CGAMC has authorities over advanced manufacturing parts certification. And so with those authorities, I think we're going to see, and MilSpec 32615, it's going to provide us some left and right leeway that we've not had in the past.
Agreed.
Yes. So Pat, this is Van. Two of the things, and I'm just adding some color to your commentary. Two of the things that we have discussed is using the relationships at UAH to quote unquote qualify this manufacturing process for production of wiring harnesses for class 1 and 2 UAS, using the IDC connectors, et cetera, and using that as a pilot project, to prove out the technology, and not just for wiring harnesses, but as a part of a scalable, automated advanced manufacturing process for the production of the small UAS systems. Semicolon and comma, we're also, looking at how do we influence the design of the small UASs to best take advantage of these advanced manufacturing capabilities. So it's a two-way street.
Hey, and Rob, I'd be remiss if I didn't let Ellis Smith from UAH kind of talk about that in their intent as well.
So yes, we're very interested in putting the machine to work right now in programs that we are building small UAS for. The wiring harnesses are a bottleneck in production. So I see this as a facility to get past that bottleneck very quickly. That will not only give us the production rate that we need of the wiring harnesses, but guarantee quality and repeatability. So there's just layer upon layer of benefit to having this kind of capability to develop for our current SUAS and future SUAS programs.
And Rob, I want to give you a chance to respond, but before we do that, I want Chris, I'm going to ask him a little bit about quality and how he was thinking about that as they went through the design and the development of the capability.
So one of the things that we've had to consider quite a lot with automation like this is that we don't want to manufacture the substrate. So let's say the class 1 vehicle that we're talking about here is manufactured on a different process that comes into our machine with a set of tolerances. Things aren't exactly where we want them to be digitally. So what we need to do is we make a machine that's capable of copes with those decisions. It can scan the surface, look at fiducial marks that we've integrated into the design of the part, and deploy the wire onto that component that's precise enough for that particular component within the machine itself. Now that the ability for the robot to be flexible and to work with the devices in front of it is inherent in all humans, but it's difficult for robots to normally cope with. And that's something that the kind of like the fundamental level of our machine, the fact that we can take these substrates that have their own tolerances and are generally kind of low tolerant, and first give you a gate. Should I continue? This is in or out of tolerance straight away. Okay, it's in tolerance now. I'm going to deploy the wire exactly onto this part as this part needs.
Yep. And I hope that, I know it resonated with Chase, but that fiduciary marking and how they go about that to make sure that we have reference marks that they can then calibrate on as they go through the production process is actually pretty neat. It's an incredible technique that I think is going to be special for this specific machine. And Rob, we'll stand by, and any questions or additional comments that you and Chase might have. Really, Chris is the expert here and can help answer.
So the one of the things that's kind of going through my mind, I keep going back to the capability as a service, and I think that helps us with speed. at the same time, we're working automated solutions in other areas, not specific to this, right? Like one example would be like automated sandblasting, right? But in our work to establish that, we have found programs within ASALT where if we can describe a project to insert capability into a facility like ours, there is at least a little bit of seed funding for that. So my mind is going more towards, right? So clearly impressed with the capability. And I agree with the comments made that, you know, when you look at some of the future work, you know, that's coming down, the repeatability and level of quality and the numbers require a capability like this. My mind's going to, you know, methods of establishing the capability, getting trained up on it, right? How that looks from the organization sense. So I think that definitely excited to see when you guys in Huntsville get the machine. We would, if you all were open to it, we'd definitely be interested in headed down to take a look at it, and just I guess share some stories there and talk about what you're seeing and where we could go from there. So those are my thoughts for right now, Pat. My mind space is more in line of how do we, right, work to establish a capability like this, get it up and running, ensure that we get it into the acquisition and sustainment world.
Yeah. So I think there's two things to respond to that. I think number one, y'all have a fairly solid use case with Sky Foundry. And I think that as you know, Colonel Crocker and the team think about how they want to move that forward, and you look at those 5 specific components that are part of Sky Foundry, that this may help fill an important gap that could be established. So I think there's one opportunity right there. And look, we don't know the requirements per se. We know there's a capability here that has incredible potential to fulfill your list of requirements. So sometimes it'll be a journey. And as you understand, part of the acquisition strategy going forward, it says, let's bring in capabilities that are a little bit less mature so that when we build out the capability, it's going to fulfill the requirements that you uniquely have. Instead of going waterfall, let's be agile. And that's why we want to start with UAH, but let's be agile and work together toward an end game that's going to give you a production ready, full capable. Here's the other thing. Because of the way that we intend on delivering this product as a service, it gives you options with how you fund. So you say, well, I need acquisition authorities. Not necessarily. It's as a service. It's operational funds that we could leverage. And so as you think about the ROI based on the operational funds that would be established, then there's a business case there that you could consider as well. And Chase, I just saw, did Rob drop?
Yeah, it looks like he dropped off, might have network issues.
Okay, well, it seems to be a trend today. But Chase, did that make sense? Did that kind of make sense to you? And I'm sure you or Chief can share that with him. But I think there's options. And here's what I'd like to do as we think about way ahead. He said, hey, why don't you guys come up to Toby? We'd like to come to Toby. And we'd like to go into AMC to provide a business case for how this could work. And we understand that there are certain amounts of funding available for different types of projects. So we want to get in on the front end of those projects so we can take this journey together and not wait for a final solution that may not allow us to grow the capability as a team.
Yeah, no, understood and agreed. Two questions. One is a little bit more straightforward. Do you have that or a tiered system for the subscription as a service? Do you have numbers yet at this point?
Yeah, so if I were to come to Toby Hanna under invite by the Toby Hanna leadership, I would bring those numbers to have discussion with, because what we're sensitive to is putting something out too early when we don't have a full vision for the project or the operational integration.
Sure. Okay. And then second, specifically on software. So we suffer from DoD cybersecurity requirements with all of our CNC equipment.
Yeah.
So I see your software. I'm familiar that, you know, it's most efficient if my engineers with 3D modeling software can network right up to the machine and push the programs over to it. That's the best bang for our buck with that. So how can we, or can I send you cybersecurity requirements that your team can start maybe working through, or we both together can work through cybersecurity requirements and considerations for your hardware and your software?
Yeah, Chase,
So-
this is Van. I'll take that one. Yeah, that's one of the things that we're going to take on as Molrex/Tritium is to work that piece. And so Pat can talk about what we're already got started as far as going through a bill of materials and the inspections and et cetera. That's something we have experience with as a company. So
Awesome.
we're going to take that piece on, and yes, we will work with you and whoever else, you know, we need to as we go to make sure we're meeting those requirements.
Perfect.
Yeah, the
Yeah.
rule
Hey,
number
and
rule
hey-
number one is Van doesn't go to jail.
Right. And Chase, as you can understand, Q5D has already started a journey with us, and we have a consulting engineer who's supporting us as well. And so we've started the hardware software BOM review, right? And the configuration review. So that's point number one. And where there are challenges, Chris here understands the software and how it's configured, and we'll be able to either mitigate them or do something else. Here's the beauty of it. And I want Chris to explain how he's got the software set up right now, and then how we can in the future potentially network it through an ICN.
Yeah, so the CAD package where you design your component can be any CAD package and completely remote from the machine. Similarly, if you want to, you can completely remotely design the CAM file. So you de-evolve that CAD file you've got into some toolpaths, very similar to subtractive manufacturing. And then if you want to, you don't have to network the machine. You can walk straight up the machine with a USB drive, give it that data.
We can't.
He meant CD. Hey, he meant CD.
We need to burn a CD, but
It's
I
a
got you.
CD. It's okay.
Yeah, I'm
Freaked out.
I'm tracking.
And then, and as we get to the stage where you've scrutinized our software to make sure that it's safe for your cybersecurity rules, then you can just plug the machine straight into the network, and you can dump those files straight into the system, ready for you to take from your design PC straight through to manufacturing.
Hey, and Chase, when I think about this is the same thing we're doing at JMC right now. What he has is
Yeah, no doubt.
or at JMTC, you know what I mean?
Yeah, I hear you. Hardware, no issue. That's exactly for every piece of our CNC equipment. That's how we have to do it. We have to sneaker net things over. The software is where I'm really concerned, and is where we're getting a lot of rejections from our Mid-Atlantic Network Engineering Center in the G6. Is they're just straight up shutting down some of our fiber CNC fiber laser software. They're pigeonholing us to certain third-party software that we have to use. So it's really the hardware thing. We'll figure it out. It's a software bit. If we could get that ATO for the software, that would be outstanding.
Yeah, Rob, just FYI, Rob is back on, so I just want to make sure y'all knew that. Yeah.
We won't
Hey, I
say anything
apologize.
important.
We're
go.
having
Hey,
technical
I want-
issues
I
on
want-
both sides.
Yeah, Chief, hang on just a sec. I want Chris to kind of talk through that, and I've got one more comment on the ATO.
Okay, so all the software that's running on the machine and the firmware as well is entirely owned by Q5D, and we own the source code for that software. So we're open book. We can help you scrutinize that to make sure there's nothing in there you don't like. And then on our supply chain, on our digital supply chain, we use Siemens NX for designing components. So that's out there, and I suspect there's already units that you've got using that software. So that might have been already ticked off on your checklist. So I think it should be a fairly easy process for you guys to scrutinize what we're doing here and to make sure it passes any tests you've got.
Yeah, because Jason, you understand this. I mean, we start standalone and then we figure out how we get it on the ICN if that's necessary. We use the baseline ATO for Siemens, and then we can use an IATO as a modification to add it in to that, the functionality into that Siemens ATO.
Hey, so what I was going to say is, so we here at CCOM have a lot of, above baseline software, and we have the dev environment. The question I would have is, would that software be able to, and Chase, this would be more of a question for you, but I could get you with our LTSD, or the logistics technical support director team, to see if you couldn't get in a Dren environment and run that software. I don't know what that entails, but I know our LTSD is in that space, and so is SEC.
Yeah,
Thanks,
tracking chief.
Hey, Rob, we're running up on time, and I want to honor your all's time and appreciate, your willingness to meet with us today. Let me just check. I mean, I offered to come up when you were off. I offered Chase the opportunity to come up and talk a little bit more about operational model pricing and ConOp. And I'm really willing to do that. We want to continue to push this through AMC as well. Won't do it without your nod, but Colonel Crocker and Joe Mohan are aware of the capability. We want to continue to pursue it. So we do have funding lined up when the time comes, but we won't do that without, ensuring that we're completely flat and that you guys are in agreement that you're willing to go on this journey in some form. And I'm not asking for an answer today. I'm saying I'd like to continue the discussions, and we believe those are some of the steps that we have to take. I don't want to wait until April till we get the UAH machine, if that's okay. I want to continue collaboration with you and your team to make sure that we have appropriately test driven the capability. And then when we do buy, that the risk is low enough that it's assumable and we're going to see outputs rather quickly. Over.
Yeah, Pat, I definitely agree. I'm with you. So this is where we need to be and where we want to go, right? With this type of capability. I agree with you. I wouldn't want to just sit and wait until April either. Also agree that if you're willing to come up here to continue the discussion and establish those steps forward, I think there are a couple different avenues. I agree with you. Obviously, we have to get through obviously CCOM AMC, get that support. When you talk about traditional buying, right, there's budget timelines. However, there are also there are other ways as well that have different timelines, right? None of it's super fast, right? But budget timelines typically 2 years. I think we can get under that if and when the time arises. So I definitely think a further conversation would be value added. In the meantime, while we wait to see the machine itself, I think internally, Chase has observed enough where we can talk about use cases and where we think things could fit. And I heard you talk about some of the typical challenges we see, ATO being one of them. And so I think all of that enables the battlefield, right? I think we could set and identify the environment and battlefield as we move forward into the spring. So open invitation.
Yeah, thanks. Hey,
you want come up, let's do it.
And Rob, I've had good fortune to be talking to our friends at Office of the Secretary of War, ANS, specifically to John Schultz. And then we're also looking at partnerships with Steve McKee and his team. And we talked about the upcoming NDAA and the language that's going to drive us in this direction. And you're going to see language in the new NDAA. They're still in conference. We expect it to come out before Thanksgiving. But we're going to see language that's going to drive us toward the acceleration of advanced manufacturing and the onshoring of capabilities. And so we believe that this perfectly aligns with that. And I can share that alignment with you when I come up.
100%. I fully agree.
We believe that if there is money this year if there is money this year and you guys are willing to go on this journey and we can help facilitate that. I don't want to get ahead of you from a readiness standpoint, but we think from the standpoint of Q5D and Mulrichs that we could have something available to you before the end of the fiscal year.
Yeah, and I agree. And with the environment, and you kind of just alluded to it, right? With Secretary of War, and where we see things going, right? Once upon a time, we were successful because we had many shovel-ready facility projects, right? And years ago, it was all about, are you ready to push the trigger now? I'm seeing the same thing starting to set up in this advanced manufacturing realm, where, hey, if you got a project and it meets the advanced manufacturing foothold and you can provide value, it's, just be ready to pull that trigger. I think this falls into that bucket. So.
Thank you. Okay. And so I'll set a follow-up. We'll come up and talk and I'll give you a better laydown to those things, the CONOP, some of the pricing, some of the timelines, and all of that, those other questions, if that's okay.
No, absolutely. May I make a request?
Yes.
When we do that, when we sit down, would it be possible for what we've seen from your machines, if there could be video footage, right? What Chase and I saw today, I would like more people in our team to see that. And understand, hey, I had connectivity issues as well, right? That's all good. But I know one of the things we did for microelectronics, as we were being asked to showcase the capability, we very specifically made, it was almost like a PAO video, but it's centered in on the essential points. Like you were showing us where and how the wire was being laid on that second machine. On the first machine, you're showing exactly how it crimped and where it laid it and the controls that it had. I would like our team to see that, our grader team. And so if I can make a request, if that can be recorded somehow, some way in a 5-minute video where our team could see it, and that way they don't just have to listen to Chase and I, we can show them.
No, I agree. You got it. That is absolutely. So we took the tip at sharing some of that yesterday, but I'd like to get you a more focused YouTube type video, and we can work that with the team here.
And for us, hey, it doesn't have to be pretty. We're going to look at it from a technical capability point of view. So I'm not asking for any, whichever way you can do it, but we don't have to make it. I know some people ask us and our marketing folks get on it, and I'm not asking for a marketing thing. I want to showcase the capability internal to the team. I think that'd be really value added.
Yes, sir. We'll deliver that. Thank you.
Yeah.
Hey, sir. Part of that update that's going to get pushed up to you from Nick will include slides from the team that have embedded YouTube videos similar to what you're asking for.
Awesome.
And the team here committed to providing one more that'll help advance it just a little bit more, in addition to what you're seeing inside of that slide deck, Chase. Rob, anything else for today? We appreciate your time. We're just a little bit over, but we sure do appreciate it. And thanks, Chase, for being here. Hey, and Rob, if you do have a requirement to come over, I know you got work over here. If you do have a requirement to come over and you get anywhere close to London, I would really like to get you down to their facility so you can see what I've seen, which is an incredible collection of some great engineering minds and some application as it relates to what they've developed. And I think that our ability to make the leap for Ellis and I, our ability to make the leap into what we know our force is going to need in the future across DOD was pretty quick. And I think you could take that same journey with us. And of course, I want to bring this capability in and make it a journey with the Army and Department of Defense and our defense industrial base partners. Absolutely.
I would definitely be open to that. I think that's something we talk about when we're together on how we can make that happen. I would most likely have to, or anybody from Toby Hand would have to line it up with other work we have going on in the regions
Yeah.
around there or in the region. So, but I'd definitely be interested in like, location where we can then arrange that to our greater region. But I'd definitely be interested in that.
Thanks. Hey, Van, anything before we close out?
Nope, I think we're good. Thank you.
Thanks, Rob. I look forward to talking soon. Thanks, Chase.
Thanks, team. Appreciate your time.
Thanks,
All right,
everybody.
we'll see you.
Thanks all. Nice meeting you.
Thanks, bye.
Thanks. Well done, guys.